Subway Surfer is one of the most popular mobile game and it's a dream project for many aspiring game developers. In this series, I'm going to guide you through creating your own Subway Surfer inspired game, and I'll be providing the complete source code for free. We are starting with very basic project setup with an introductory environment and very iconic character Jake. All these files are available in our Discord server. This series will cover the fundamental steps, character controller, collision detection, and the chunk generation. So let's get started. The character controller in the Subway Surfer is a crucial component in the game. To start, we need a humanoid rig character and the character controller component, which we will access via script. And the script is divided into two main parts: forward movement and the lane movement. For forward movement, first we will create a serialized public variable for the forward speed, which we can access through the inspector. Then define a method called handle forward movement. In this method, we will multiply transform.forward by forward speed and time.delta time, storing the result into vector3 variable. Convert this local vector into the world vector and use the controller.move method to move the character forward. So far, this has been the simplest part of our script. To implement the lane movement, our character should be able to move between predefined lanes. We'll use traditional approach by setting specific values for each lane: 0 for the leftmost lane, 1 for the middle lane, and 2 for the rightmost lane. First, we need to define two variables. The first variable is for the target lane, which we will initialize to 1, that middle lane by default. The second variable is for the lane distance, which will determine the distance between each lanes. We'll create another function to handle the lane switching. This function will take input from player. If left arrow is pressed, the move lane direction value will be set to -1. Similarly, if right arrow key is pressed, the move lane direction will be set to 1. Next, we'll create a new function that takes integer as input and names that direction. This function will add up the value to the target lane variable. Since our lane values ranges from 0 to 2, we'll use mathClamp function to ensure target lane values stay within the range, preventing our character from moving out of the bounds. Now let's review what we have done. The handle lane switching function checks for the player input and passes the appropriate value to the move lane function. The move lane function calculates the new target lane value based upon its input. Next, we'll create a method for movement between lanes. The above code only specifies the lane values, not the character movement to the targeted position. Thus, let's define a function to calculate the target position. We'll start by keeping the character Z and Y values remain unchanged and store these values in variable called targeted position. Next, we'll add the condition to check the character's current lane. If the character is in the leftmost lane, we'll add up the lane distance to the targeted position. Similarly, for the right lane, we'll adjust the targeted position accordingly. This function then will return the calculated target position. Let's make another function. Then we'll take the position named as targeted position. On this function is calculating the targeted position of character. In every frame, this function will check if the character has reached the targeted position. If the character is already in targeted, this function will return early. If not, this function will execute the following lines to move the character towards the target. You don't need to dive into the specific of this formula. Essentially, this code calculates the difference between targeted position and the current position, then normalize it and multiply it by the speed. This condition checks if the square magnitude of move direction is less than the difference. If it is, the controller will move by move direction. Otherwise, it will move directly to the targeted position. I know some of you will totally confused here. Now let's understand the flow of this code. This method will take the input, then target lane values will be decided by this method. Now we just have the lane values. For the movement, this function calculates the targeted position, and lastly, this code of block will move our player to that lane by using the difference formula. Now last, we'll play the dodge left and the right animation and by default run animation. For now, our basic character controller is ready. You can access these files in our Discord server. For now, thanks for watching. Collision detection is a crucial in game development, but in Subway Surfers, it's particularly challenging. Unlike basic games, you can't just add the tag to detect the collision due to constant movement on the trains. Today, we'll build a simple collision detection system for a Subway Surfers So let's dive in. So basically, there's a two major problem in the game. Problem 1, when moving on the top of the train, if you use tags, a character will die because of tags on the train. This can be solved by using multiple colliders on train. Problem 2, relative animation. When a character dies or stumbles, corresponding animation should play. Using tags makes this difficult. We're going to create a simple script to address these all issues. In Unity, there's a 3 basic method for collision detection, using colliders and rigid bodies, as seen in many endless runner games, using overlapping method, which some people have used before, using raycast method. We're going to use raycast method in a very simple way. Let me explain. We'll cast a ray from the front and the side of character. If the ray detects the train from the front or side, it will play the corresponding animation, like stumbling from the side, dying from the front. Very simple. First, we'll create 2 enums, hit Z with the values forward, backward, none and mid, and similar one for hit Y. We need 3 variables, one for raycast range, one for raycast origin, a boolean dead which is false by default. Now let's create a proper method of front collision check. For that, we throw a ray from the head position and check the condition. If hits the train, it will return 2 values, hit Z forward value, hit Y lower value. This occurs when ray from the head position collides. And finally, set that to true. Now create a separate function for the death animation. Check the conditions. If hit Z is forward and hit Y is lower, then lower death animation will play. Do same thing for hurdles. For upper death animation, both head and feet ray must collide with the train or hurdle, like when jumping. Set the feet position a little bit lower so upper animation doesn't play in lower state. When jumping, both rays will collide with the train or hurdle, triggering the upper animation. For stumble animation, left and right, simply send the rays from both hand positions and play the corresponding stumble animations. One more thing, I've added the camera shake script from Asset Store, so when stumbles or death animation play, the camera will shake. Now let's test it. In the last section, we covered the basic of character movement. For jumping and rolling, I'll speed up this part so you can follow the code without any lengthy explanations. Next, we need to focus on the junk generation, which is a critical aspect of making our game an endless runner game. This is where we'll spawn the random chunks as character moves forward and remove the old ones. We need few variables to get started. Now, just follow along as I walk you through the rest.